This video is on integration using residues. In today's video, we are going to solve the problem using residue theorem. See here, first of all, we have to evaluate integral 1 by z square plus 4 whole square into dz, where c is mod z minus I is equal to 2. So clearly, this is integral f of z into dz. So what is the function value given? So the function value f of z is given as 1 by this is z square plus 4 whole square. Clear? So in order to find the poles for this function, so what we have to do? So we have to equate the denominator to 0. So here the denominator value is nothing but z square plus 4 whole square. So we have to equate this to 0. So this can be written as this is z square minus of this is 2y whole square. Clear? So we can write in this form. So this is 2 square, this is 4, and I square minus 1. So minus of minus plus 1. So as it is in the form a square minus b square, so this can be written as a plus b into this is a minus b. A minus b is equal to 0 as there is a square outside. See here, for each and every term I am squaring. So here f of z can be written as, so after equating, that is z plus 2i whole square to 0, and here this side z minus 2i whole square to 0. So here we got z value as, so z value as minus 2i, which is a pole of order 2. So this is a pole of order 2, and here z value is equal to plus 2i, which is again a pole of order 2, which is a pole of order 2. So we got the two pole values here. First one is z is equal to minus 2i, and z value here is plus 2i. So both of order 2, and clearly, so f of z can be now written as, so f of z value can be written as, see, f of z is equal to 1 by this is z plus 2i whole square into z minus 2i whole square. So this is our f of z value. Now see here, what is the condition given? The condition given is z minus I is equal to 2. So f of z value lies within this one, that is mod z minus I is equal to 2. So this is a circle value with center I and radius 2 here. See, let me explain you this one. So as this is x-axis and this is y-axis. So here we have to write like this, that is 1, 2, 3, 4. Here also minus 1, minus 2, minus 3 and minus 4. Here this can be written as I, 2i, 3i, 4i, and here down minus I, minus 2i, minus 3i, minus 4i. So if you observe this one, so here is a circle with center 1. So here is a center point which is 1, which is I. Center is I, and we have to take 2 as radius. See, take one circular and draw with 2 radius. A circle is drawn, and here if you observe this one, so we have the two poles here as plus 2i and minus 2i. So if you observe, that is 2i is within the circle and minus 2i is outside the circle. So in order to calculate this integral f of z dz using residue theorem, so we have to calculate only the residues which are inside the circle. So here inside residue is nothing but 2i. So we have to neglect this one, that is minus 2i, and we have to proceed. See, clear? Did you understand? So here plus 2i value is needed for finding the residue. For finding the residue, so here the residue value is the residue of f of z I am writing. Now for finding the residue value at z is equal to 2i, positive 2i. The residue of f of z at z is equal to z naught is nothing but this is limit z tends to z naught 1 by m minus 1 factorial into this is d by dz power this is m minus 1 into this is z minus z naught into f of z. Clear? And here m value is equal to, so the order value here is m. Order value is equal to 2 here. So here the pole order value is equal to 2, and here z naught value is equal to 2i. So f of z value is also very clear here. F of z value is this one. So now I can calculate the residue value. So the residue value of f of z, see here, the residue value of f of z at point z is equal to plus 2i is nothing but this is limit z tends to 2i 1 by m minus 1. So that is 2 minus 1 factorial into d by dz power, this is 2 minus 1 into this is z minus 2i into f of z. So f of z is this one, that is z plus 2i square into here this value is power m. So this is power m, z minus z not power m. So this value will be square and this is z minus 2i square. And now I can cancel this one in the numerator as well as denominator and see this value will be 2 minus 1 factorial is again 1. So this can be written as limit z tends to 2i. This value is d by dz power 1. So one time we have to make a derivative for 1 by this is z plus 2i whole square. So here is the derivative. So for derivative of 1 by x square. So here the derivative of 1 by x square is nothing but minus 2 by x cube. Remember, minus 2 by x cube. So this will be limit z tends to 2i. So if I make a derivative, this will be minus 2 by this value is x power 3. And again we have to substitute 2i in place of this one. So this will be minus 2 by this value is 2i plus 2i whole cube. So which is equal to minus 2 by this is 4i whole cube. So this value is nothing but minus 2 by 4 cube is nothing but 64 and I cube, as you know that I square value is minus 1. So among these three, I square minus 1 and 1 remains. So if I cancel this one in 2 table, this is 32 and minus minus got cancelled. So this value will be 32i. So this value is 32i. So the residue value of f of z at the interior pole z is equal to 2i. So here for z is equal to 2i, we got the pole value as this one. So according to the residue theorem, so what is our residue theorem? So according to residue theorem, integral f of z dz is nothing but 2 pi I into the sum of the residues, the sum of the residues at interior poles, at interior poles. So here our residue value is nothing but the question here is, so let me show you. The question here is dz by z square plus 4 whole square. So this is dz by this is z square plus 4 whole square is equal to this is 2 pi I into the interior poles is nothing but 1 by 32i. So I can cancel I and here it goes in 16 times. What remains? Therefore, dz by this is z square plus 4 whole square is nothing but this value is pi by 16. So pi by 16 is our value. So this is how we have to solve and let me explain you once again. See, first of all, it is given that we have to evaluate integral f of z dz where c is mod z minus I is equal to 2. So f of z is this one, and in order to find the poles we have to equate the denominator to 0, and after writing in the form of a square minus b square, this is a plus b into a minus b, and after equating to 0, so we got z is equal to minus 2i is a pole of order 2 and z is equal to plus 2i is also a pole of order 2. So f of z can be transformed as 1 by z plus 2i square into z minus 2i square. Here the condition given here is the circle value is z minus I is equal to 2. So z minus I is equal to 2 is nothing but a circle with center I and radius 2. So we have to take 2 as a radius, and if you draw a circle like this, so plus 2i is within the circle and minus 2i is outside the circle. So we have to neglect this one and we have to calculate the residue at this pole value 2i. So after calculating the pole value, as it is of order 2, this is the formula. So m order value is equal to 2 and the pole value is equal to 2i, and after calculating we got the pole value as 1 by 32i. So according to our residue theorem, so integral f of z dz is nothing but 2 pi I into sum of the residues at the interior poles, that is 2 pi I into 1 by 32i, and after cancelling I and after cancelling 2 from the numerator and denominator, what remained here, this value is nothing but pi by 16 is the value. So this is the most important question, essay question. Please practice, and definitely it will be very helpful for your preparation. And if you really like, please pass it on to your friends.